which I'll call y. Okay. So let's just say we thought we could find, well, let's go at it from the right angle. Let's say like I believe it ended up being BF. Do you remember from yesterday if I said that?
Yeah, I think you said it. Yeah,
Okay, so
it was
let's
one of the.
let's go in the direction of that's being correct. What they're trying to show you is that the let me draw this here. This line is parallel to this line. All right, and then that creates two triangles. It creates the big one, ACB, and you know that this is 30, this is 24 plus y, and this is 6 plus x. All right, so then the smaller one, we have 18 and 24. And what you have to do is figure out, well, how do I go from 18 to 30? 18 times k equals 30. K equals 30 divided by 18, which is 5/3. Okay. Is that okay so far?
Yeah.
So similarly now you got to take this 24 here and multiply it by 5/3. The 24 times 5/3 is supposed to equal 24 plus y. So 24 times 5/3 ends up being 40. Okay. And then you subtract and you find that y is 16. And that is a number there. Okay. It is a number there. So then that does correspond to y, and that is BF. Okay. Now, I only knew to do that because we kind of already did it yesterday. If we tried to use the other two triangles, we would not have gotten either of these numbers. Do you want me to show you that now?
Yeah.
Okay, so I'm gonna reframe the problem here. So this time you're looking at it as if DE is parallel to BC. Okay, I'm gonna use the same letters again, Y and X. So there's the big triangle again, which is the same, A, B, C, X plus 6, 30, 24 plus Y, or Y plus 24. And then this time though, it's the little one, 6 to 12 for ADE. This time you're going from 12 to 30. So 12 times K equals 30. K equals 30 over 12. That ends up being 5/2. All right, so same process. Now we say, okay, let's apply that to the one here, the 6. We can only apply it to the 6. Like we can't find y is I guess the point. Whereas in the previous problem we could, because the 6 goes with the AB or X plus 6. So to do that, you take 6 times 5/2, and that's supposed to equal X plus 6. That's 15 equals X plus 6. Subtract and you get X equals 9, which is there, but it's not BF. It's BD is the one that we're looking for X.
Got it. So all right, the correct answer for this one is gonna be BF equals
Yeah, 16. That's the
16. So yeah, going that was all right. I think that makes sense now.
awesome.
Okay, there's one of these written questions in here as well I'd like to go over. Let me put, this is number 9. One of the written questions. It's in the chat now.
All right, there we go. Okay. All right. So Seth is using the figure down below to prove the Pythagorean theorem using triangle similarity. Okay, that's nice. The given triangle DEF, angle D, sorry, is 90. Segment DG is perpendicular to segment EF. Identify a pair of similar triangles. All right. So this is really similar to a problem we did yesterday or recently, where they like gave you the proof, but it was you were trying to figure out which thing they were not using, and it ended up being like the transitive property or the angle addition property.
Yeah.
So if we just look at what's going on here, this is 90, that's fine. Okay, so this is 90 and this is 90. And then what do we have here? EG, EF. Okay, so I think what they're going to have you show is that the big triangle is similar to one of the other smaller triangles. Let me do a quick check on this because I haven't seen this in a while. And hold on. Thankfully, this has probably been done a lot, so it's
Yeah, I
it won't
found
be
another,
won't be that.
yeah, because I found a good way to check some of these. Like the other day, I was kind of confused on one of the questions. I wanted to see how somebody else did it, the process of how they did it, not the answer. So I I looked it up on, and somebody had like their work on there, so I was able to see how they kind of did it for that
Yeah, you just
particular
got to be
type of
careful
problem.
that their work is like upvoted, or that you actually believe that it's it's
Yeah,
right.
of course,
Um,
yeah.
um, okay, so our similar triangles, we can use AA and then what else? So ABC congruent to ABD. Okay, by that. All right. So what I'm seeing here is that for part A, identify a pair of similar triangles. So all right angles are equal. That's one of them. And then do they share an angle? Okay, great. So here is how it's almost like we have to do part B first, but do you think we can just say which triangles are similar, or if we have to,
Well, if it's
or do we like it's almost like we need to do part B first to explain it and then say that they're similar. But okay, so let me show you what I'm thinking here. The big triangle is DEF, okay, and then the little triangle EGD, okay. Do you see how they have two right angles that are the same?
yeah,
And that angle E is shared in both of them.
Yeah.
That is our justification for, like, that's how we're gonna say how we know it. It's through AA. So for part A, we are going to say that triangle, the order matters here. Let's go D, E, F, similar to, now notice you're starting at the 90-degree angle, going to the angle E, so it's similar to triangle G, E, B. Okay. It just says to identify. Okay. We've done it. In part B, we're going to do the actual like, I guess, almost a proof, I guess, if you will. Let me know when you're ready for part B.
Okay, let's. Angle E, G. All right, yeah, I think I'm ready to move on to, so, yeah, so we're doing, I think part two, never mind, all right, so for
Ready for part B?
yeah.
Okay. So I think we should just do it as a proof. Are you okay with that?
Yeah, yeah.
Okay. So we're given so SR, we are given that EDF, triangle EDF, is a right triangle with right angle B. And then we're also given that BG is perpendicular to segment EF.
Yeah.
Okay, these are both given like that. Okay, so now where we go from this, and you can either call this 1 and 2 or they're both 1. Where we're going with this is that angle BGE is a 90-degree angle. So angle BGE is a right angle. And that comes from the definition of a perpendicular.
EDF, sorry, right angle. Oh yeah, I what you're saying was for first, right?
Is that okay so far?
Triangle. One second. Triangle. EDF or angle. Media is right angle. Because angle Right. D. DG is perpendicular to EF. D. DG yeah. That's perpendicular. That G is a right. DE is a definition of a perpendicular.
I'm gonna be right back here.
All right, no problem.
Let me know when you're ready for us to proceed
So
here.
would it be definition of perpendicular lines as the justification for DG is a right angle?
Well, yeah, I mean, it's a perpendicular, so that is what a perpendicular does. You could say definition of a
So that's
sort of
definition of
perpendicular. I guess you could add in segment.
all right, yeah, I'm ready to move on.
Okay, now the next thing is that you say that angle BGE is congruent. The angle we just mentioned is congruent to angle EDF. EDF. And that's because all right angles are congruent. So we have one of two angles congruent that we need.
Right. So the justification for that would be all right angles are congruent. All right,
Right. So the next thing we can say is that and we already, kind of already have this, is that angle E is congruent to angle E, but we can't just say that. We have to say the three letters. So we'll say DEF, we'll try it at that right angle. DEF is congruent to GED.
Con-
So DEF is congruent to GED. Okay, and the justification for that is that they are common. So common angles, meaning that they're the same, like they're literally the same. Common angles are congruent. Sometimes you just write the word common for shorthand.
Our coning was written current. All right, I got it now.
Okay, so that's enough to say that they are similar. So triangle, and it's before we go back to the whole thing we're trying to prove here, that's right here, that they're similar. The order of the letters matters. Out of here. So they are similar because you have two angles. So you say AA similarity.
DEF and GED are congruent by a similarity. Sure. Here. Congruent. A. Postulate. All right.
It's that should be everything for part B. Because we've completely proved the similarity. It's great. Um,
Um,
okay, so we can now do part C, which does require us to look at these two triangles here. Let me know when you're ready for part C.
all right. There we go. All right, yeah, now I'm ready for part C.
So the thing that again, like, because these aren't oriented quite right, like you gotta be careful with your mapping of things. So EG is 2, okay, but EG goes with ED. Okay, and EF is 8. Okay, so you might be wondering, well, how am I even going to do this? Well, ED and ED are the same. You see that they're the same?
Yeah.
Okay, and that's what we want to find. We want to find ED, thankfully. So we're going to set up a proportion here. We're going to use the small triangle over here on the left. and then the hypotenuse on the top. So the hypotenuse of the smaller triangle is x. Okay. So in the larger triangle, the hypotenuse is 8.
Yeah, because you can kind of see it's like the longer side. I don't know.
Is that okay?
Yeah.
All right. Now we got to go for the other side. So we're going to go with the EG side, which is, I don't really know what to call it. I'm just going to call it a leg in the small triangle. That's 2. Okay. Well, what does that go along with? Well, we just said it goes along with the one that goes from the E to the G, or the 2 to the 90, the X over here in the large triangle. Is that okay? Clear?
Yeah. Hello, can you hear me?
Yes. Just making sure that's okay. So we're
Yeah.
just going to solve this proportion by cross multiplying. X squared equals 16. So X equals 4. You might wonder why. Well, why isn't -4? Well, it's because it's got to be a positive number. It's a length. So the ED, which is equal to X, is 4.
One second. Let me just- All right, I got it. Yeah. Good.
All right. Well, you want to send over something else, or start working on something else? We can look at it together.
Yeah, let me- All right. There's another written one. This is number 10. Another sort of multi-part question. You put it in the chat now. All right, the chat.
All right, there it is. All right, the diagram below models the layout at a carnival where G, R, P, C, B, and E are various locations in the grounds. GRPC is parallelogram. Okay, so that's important here. So the fact that it's a parallelogram means that opposite sides are parallel, but more importantly, opposite sides are congruent. So the 400 on the left here is the same as the 400 on the right. On the, I don't even know if we're going to need this, but the 350, 250, which is 600, is the same as up here. All right. It also helps with what we've been trying to, this whole like, what are we trying to figure out in terms of like similar triangles? So the parallel lines really help to do this. So let me see if I can show there. So this line being parallel to this line is going to reveal that triangle, the big one, GRE, which has, and I'll call this X, has 450 plus X like that. And then we've got, well, actually, we do know that the full length is 600. And then we've got the smaller one, the smaller triangle here, X. And then we know that this is 250. Now, how do we know? So in terms of like part A, let me be clear here. So part A, all this is like leads into part A. So we know that triangle, I need to label this, triangle EBP similar to triangle EGR. So you have to follow the same trajectory, EPB, EGR, like that.
Got it. So wait 1 second. So EBPs and EGR. EBG. One second, I realized it was not for this question. I'm trying. EBP is weird to EGR. EBP is congruent to EGR. Right. All right.
Is that clear?
Yeah.
Okay. Now we have to now explain how we know, and I guess we could do a proof again, but maybe we do it a little differently. Maybe we'll do it more in words, or like a paragraph proof. So we can say that that angle, well, right out here. So angle GER, G to E to R is congruent to angle BEP because they are common. They are common angles. Okay. That's the easy part of this. There's quite a bit more to do.
All right, I think got that.
Okay. Now, we have to go back to the fact that this is a parallelogram. Since GRPC is a parallelogram, that means that GR and CP are parallel, okay? So you want to say, since GRPC is a parallelogram,
Since
G,
GRPC.
GR is parallel to CP. And we can say, and furthermore, we should actually go a little further. And I'll just say RT is a transversal. So if you look at your picture, that's the one kind of going down the side.
All right. Yeah.
Okay, so now let's go back to the what that means. That means that if I draw this line a little bit more here, that means that this angle up here, top right, VRP is congruent to angle CPE. So in terms of the triangle, that means that this angle here is congruent to this angle here. Because they're parallel, they're corresponding angles. We're going to say that now. So we're going to say that angle GRP is congruent to angle BPE by corresponding angles.
So GPR is going to GP. GPR to BP because they are corresponding angles because they're or because they are corresponding angles. Okay. Yeah, dang, I guess that now.
Is that okay?
Yeah.
All right, now that allows us by AA, we've got the first angle and the second set of angles to say that these two triangles are similar. We just have to get the right order, which is probably why they have you do that first. So you can say are similar by similarity, because you've shown the two angles are similar.
By a similarity to each other. Okay. Triangle. A similarity postulate. Also, this is kind of a minor thing, but do you need to say similarity postulate or can you just say similarity?
Probably more, so they say the postulate.
Yeah, because whenever I refer to it, you should say like similar or a similarity postulate, just to be specific. Well, I mean, yeah, but I don't think there's much difference there. But anyways, yeah.
Right. So now we can, whenever you're ready, let me know. We can get part C.
All right, let me a second. All right, yeah, now I'm ready.
Okay. That goes back to these two pictures here, these two triangles here. So we know that BP goes to 600 GR. So it's 250 times some K gets you to 600. K equals 600 divided by 250. Divide those and you end up getting 12/5 like that. Okay, now the reason that's important is it allows you to solve for BF. Okay, please let me double check that here. Definitely off today. 250, yeah, 2.4. Okay. So what that allows you to do is the same thing for the one. Now we're used to there being a number, but you can still do it with, because there's only a single variable. So it's X times 12/5 equals 450 plus X. Okay, and it just maybe looks worse than it is. If this is 2.4x equals 450 plus X, subtract X from both sides. And then you divide by the 1.4. So X equals 450 divided by 1.4. And wow, it does not work out nicely. That's odd. Did I make a mistake here? 350 plus 250 is 600. We are not using that length. X to X plus 450. 2.4 subtract 1.4. From E to, and from P to E. Okay. Yeah. That's interesting. Do you see any mistakes here?
And here. Let me compare it to the 250, then 250 times K, DK equals 600 divided by 250 divided by 5. 12 divided by no, there doesn't seem to be any mistake.
So the thing that bothers me is it doesn't really work out nicely, which is a little bit odd. It's not terrible. I mean, I would have expected to work out nicely because we do need to do the same thing to find the other one. So the other one here is we'll call this Y, and this is Y plus, if you go back to the picture, Y plus 400. It's the same thing. It's Y times 12/5 equals Y plus 400. So it's 2.4 Y equals Y plus 400. 1.4 Y equals 400. Y equals 400 over 1.4, which I kind of thought these were going to work out nice. Yeah, that one again just doesn't work out all that nice. So this is 286. And then the other one is 321. So you'll have to kind of decide if that's a problem. Or maybe you'll get some feedback on it. But I guess get that down. Let me know if you have any questions before we close out here.
All right. Do you mind again going up with just a bit?
Sure.
Yeah, there we go. Thanks. Oh, and by the way, I will not be needing tutoring this Thursday, Friday. And then obviously I'm not going to be scheduling one this weekend either. But then I
Okay,
need tutoring back again on Monday.
okay,
Because I'll be out for those days, so I don't need tutor, and that's like the break in between both the semesters, so I don't need tutoring those days.
got it.
But then I'll be
Got
resuming tutoring that month, like next Monday.
Sounds good.
So yeah, I just wanted to tell you that way.
I do appreciate that.
Yeah.
All right, so we do, I mean, we do have to stop here. I mean, I'm happy to send you the notes here.
Yeah, because it's all in the notes. Like,
You can't maybe get down that fast, but yeah, let's go ahead and stop here.